Let's say you got a mail from your client. You are requested to design a universal joint, considering 20 mm as shaft dia. He also mentioned documents required such as 3D model assembly, renderings, animated video, and detailed drawings. I'm gonna create all those using one software, that is Fusion 360. Without further ado, let's get started. By the end of this video, you'll learn how to design and assemble components, how to render the model, how to animate the model, and how to create detailed drawings. As per our client request, the shaft dia be 20 mm. I want to base this parameter for my entire design. For that, select parameter under modify dropdown. Add a parameter by selecting this plus icon in here. I'm gonna give it a name as D. Remember, we are going to use this parameter multiple times. You can change units in here. In my case, metric is fine. Enter the expression, our value here. You can add comment if you wish to. We just created a parameter. Congratulations! We'll begin by creating a new component. We got a component tip here which describes what it is. As you all know about this, I'll just minimize it. Let's rename our component as fork and let go. Now component fork has been created. I want you to save this file so that we may not lose it. I'm gonna name it as universal joint. Pay attention. I would like to draw a rectangle on this plane. Then I'm gonna select center rectangle. Choose origin as center and place it roughly. D on the keyboard. Now enter the height of the rectangle. I want it to be 3.2 times the dia of the shaft. Enter 3.2 times D and press enter twice so that you will be exited from the prompt. If you notice here, it added a function because we've linked this parameter with the shaft dia. 3.2 times 20. That is 64 was computed as a result. All the results are based on this. D on the keyboard. The width of the rectangle be 1.1 times D. Now press E on the keyboard. Manipulate the arrow in this direction. Now the extrude distance be negative 0.6 times D. Press enter twice to confirm. Pay attention here. I want to draw a circle on this face. For that, select sketch, then select plane and select circle. That is total 3 steps. In order to do that, total 3 steps it have taken. What if we can perform it in a single step? Let me show you how. Undo that, just right click on this face. Select sketch, hover over to circle, there you go. Whoa. You may think that's a heavy work there. Here's the magic how you can perform this very fastly. Note the power for circle, it's 645. Just hold the right mouse button and perform this action. Let's try that again. You got it right. What it did is, it went to the sketch, the face where you held right mouse button taken for sketch plane. Awesome, isn't it? This is called marking menu. Now draw a circle, origin center. I want this circle to be snapped to the edge here, but I was unable to select that. In order to do that, either we can dimension it or we can project this edge. There is one more thing which drastically saves our time, is by modifying preferences. In design, we have unchecked boxes. I want to check auto project edges on reference, auto project geometry on active sketch plane. Apply and let go. Now you can snap to that edge. Incredible, isn't it? Draw another circle concentric to last one, where the dia be D. This is our shaft dia. E on the keyboard. Select this face for extrude. Let the extrude distance be 1.1 times D. Perfect. Select circle using marking menu on this face. Draw 2 concentric circles vertical to this point. Select these 2 points and apply vertical constraint. D on the keyboard. The dia of the inner circle be 0.6 times D. The dia of the outer one is 1.6 times D. The distance from this point to this edge be 2.6 times D. Close this profile by drawing 2 lines tangential to the circle. Select trim or press T on the keyboard and select this circle. E on the keyboard, select this profile and drag it down. Let the distance be negative 0.5 times d. I want to mirror the previous feature about xy plane. Congratulations! We are done with the first component. We have to create forks. I want to copy this component. Now activate the top level assembly and select paste. Notice that we do have paste new here. You may select that, but you cannot get modifications. Copy it each time when you modify the first component, that is fork in this case. For now, I'm going with paste. Use the manipulators to change the position. I want to rotate 90 degrees about z-axis. And 90 degrees about y-axis. And let go. Then I'm gonna create a new component within the master file. Rename it as central block. I wanna hide fork 1 and 2 for a moment. Select circle using marking menu and select XY plane for sketching. Draw 2 concentric circles, origin as center. The dia of the inner one be 0.6 times d. The dia of the outer one be 1.1 times d. Press Q on the keyboard. Then select this profile for extrude. Change the direction to symmetric and measure to whole length. The distance be 2.2 times dia. Awesome. Repeat the circle but choose YZ plane for sketch and draw 2 concentric circles on y-axis. Let the inner one dia be 0.6 times d. The outer one dia be 1.1 times d. I want this point to be horizontal about origin. The distance between them be 0.8 times d. Q on the keyboard. Select this point and change the direction to symmetric and measure the whole length. The extrude distance be 2.2 times d. Change the operation to join and let go. I was unable to orbit completely. Let's change to free orbit. Perfect. If you notice here, there is an extra material inside because of the extrude and offset distance. We have to remove that. We can perform that either by projecting sketch or by modifying previous extrude and performing cut. Let's edit the previous extrude. Add this profile too. Now repeat the same for next extrude. If you are unable to select the profile there, hold the left mouse button and hover through options. Now perform press pull using marking menu. Note the position. Let's try that again, and there you go. I want to show the first sketch in central block. Select the inner profile. Repeat the direction. But extend to be all. Make sure that the operation is cut. Now show the second sketch and repeat the same for the inner profile. You guys are awesome. Hide the sketch. We are done with the central block. Let's create another component within the master file. Rename it as fork pin. Also, I would like to hide the central block for a moment. Select circle using marking menu. Choose XY plane for sketch. 2 concentric circles, origin as center. The dia of the inner one be 0.6 times d. The dia of the outer one be D. Q on the keyboard. Select the inner profile. Use the manipulator to roughly add distance. Let the extrude distance be 3.6 times D. Now enable the previous sketch under fork pin. Select the profile and press E on the keyboard. Roughly adjust the length in negative Z direction. Let the extrude distance be 0.25 times D and let go. Now create another component under fork pin. Let's rename it as collar. Select circle using marking menu. Choose this top plane on fork pin. For sketch, instead of drawing circles again, I want to project this face to reduce my time. So select this face and press P on the keyboard. Confirm the projection. Awesome. Q on the keyboard. Select this profile for extrude. Roughly position it using manipulator. And the extrude distance be 0.25 times D. You guys are doing great. Now we need to put a hole for lock pin. Select circle using marking menu. Draw a construction line between the edges. Midpoint as center, draw a circle. Let the diameter of the circle be 0.1 times D. Q on the keyboard. Hold left mouse button in order to select the profile underneath. The direction be symmetric. The extent be all. Uncheck the fork pin to cut. Perfect. Now we need the same hole on fork pin too. Activate the fork pin. We need the hole position such that the collar fit tight in its position. For that, I have to consider the fork vertical distance. As you can see here, there is enough space extra left on pin. The hole position length from bottom face of the head be vertical length of the fork and half the height of the collar. You got it. Let's revert back to the position and hide the fork for a moment. Select the circle using marking menu. Draw a circle on Z-axis. The dia be 0.1 times dia. Let's apply horizontal constraint with the origin. The distance between 2 points be 3.2 times D plus 0.125 times D. Perfect. This is what I wanted. It's high time to extrude the profile. Q on the keyboard, hold left mouse button and select the desired profile. Change the direction to symmetric and extend to all. Now uncheck collar and let go. Now create another component under fork pin and rename it as lock pin. Let's hide all bodies and components. Select circle using marking menu. And select XY plane. Draw a circle and position it roughly. Let the diameter of the circle be 0.08 times D. L on the keyboard. I want to draw a circle on the same plane but in a certain distance. For that I can offset the plane, which consumes a lot of time. There's a thing you can do. Enable 3D sketch. You can observe all setup for 3D sketch was here. Now select origin as center as one endpoint of the line. Hover over the Z-axis so that you will be snapped roughly. Position it and draw a circle on the line that created. Let the dia of the circle be 0.125 times D. The distance between two circles be 1.2 times D. Select the line and press X on the keyboard to convert it into reference. The most hardest part has completed. Now select Loft under Create menu. Select the two profiles and click OK. Awesome. We are done with all the components. Let's activate the top level assembly and show all other components. Reposition them so that we can see clearly. Oh, I was unable to see the lock pin. Where did it go? Select the lock pin in here to highlight it. There it is. Reposition it to avoid confusion. Now that all components were in their respective places, let's capture this position so that we do not revert back. It's high time to assemble all the components. Ground the central block so that we'll assemble all based on this only. Select joint in assemble, or you can press J. If you hover to the top edge of the hole, it highlights the point that you can select. I want to select the point underneath it. Just hover over the whole face until you see 3 control points. Then hold Ctrl down and snap to the bottom point and select it. Here snap to the top point. Now these two join together. Change the motion type to revolute. Awesome. You guys are doing great job. Repeat the same procedure for second fork too. Perfect. We need 2 fork pins. Select fork pin and paste it. Roughly change the position so that we don't confuse while selecting components for join. Perfect. Repeat join and select the bottom central point and control point on fork and let go. I want to change the motion type to rigid. Repeat the joint and select the top bottom point on the collar by holding Ctrl down and select the top point of the hole on fork pin. If you get like this, don't worry, flip the direction and let go. It's that easy. If you observe here, the collar for the duplicate file joined to the fork pin. This is because we simply pasted it. In order to avoid this, we have to perform paste new. For now, I'm satisfied with it and it saved me a lot of time. Repeat the joint and select the top point on the lock pin and select the top point of the collar. Roughly adjust the position using manipulator so that it looks nice and clean. If you notice here, the pin for the duplicated fork haven't joined because we're choosing the one belongs to duplicated fork pin. Let's undo that operation. Repeat the joint. Select the right top face and top point on collar. Position it roughly and let go. Notice here, the pin automatically joined. It saves us a lot of time. Repeat the joint and select the bottom face of fork pin head and a point on the top face of fork. Flip the position. Perfect. Now that we modeled and assembled it, let's hide the joints. Select these and press V on the keyboard. Repeat the same for all. If you notice here, we can move the components by selecting them. This is good, but in reality, they won't overlap, isn't it? We can modify this. For a universal joint, the angle limitation is 0 to 20 around that. But for now, we make joint limits so that they do not overlap each other. We can modify this. Notice that we copied the fork pin after creating 2 joints. I want all joints together. I can click and move the copied feature without affecting the design. Now it looks nice and clean. Now pay attention here. If you right click on the joint, we'll get many options. I want to edit joint limits. Check minimum in here. I'd like to view it from the top based on the joint pivot. Calibrate it by entering some angle in here. Let's animate the model. It shows the region between the angles. Let's make it 90 minimum and animate the model. Wow, it's coming excess. Let's try that with -90. Change the max to 90. We are getting it, guys. Now adjust the angle till you get perfect motion. Must not overlap with other components. For me, mine is 32 and 32 worked well. Perfect. Repeat the same for second joint also. Change the views so that you can have a better control. Now that they won't move beyond limit. Congratulations, you're done with the hardest part. Now let's enjoy the feast. Switch to render workspace. The options are quite different from design workspace, isn't it? But don't worry, these are very easy to handle. Let's hide the render gallery. We'll talk about in a moment. Now click on appearance under setup. You can press A on the keyboard as shortcut. Inside library, find metal and select aluminum. Drag and drop the texture which you'd like. The appearance applied to the both forks. Because we pasted it instead of paste new. Repeat the same for all. Just explore all textures, drag and drop them. It's that simple. When you're done, simply close it. Click on scene settings. This is where all magic happens. We are having many environments. Under environment library, drag and drop onto the empty workspace to apply them. We forgot to change background to environment from solid color. Also, I'd like to check flatten ground. Inside environment library, drag and drop plaza. It looks good for me. Just manipulate all other options and find out what happens. For now, I'm gonna close this. If you select in-canvas render in here, it computes the design on screen and processes the render, which may heat up your system. Here you can control in-canvas render settings. You can set resolution and all those things. You can capture canvas render using this option here. But there is cool option for your render. For the best, select high resolution inside print. It shows you credits required. If you have enough credits, you can go with it. As soon as you hit that enter button, it saves the document to that point. Yes, you can see your render processing inside the render gallery. We'll come to that later. Meanwhile, we can work on our animation. This looks quite different from the previous workspace. This is our timeline. It looks like render gallery, isn't it? But it's not. Let's bring our playhead to the start. Let's change the view so that we can see all the components including lock pin. We can orbit, or you can select the faces or corners, whatever, on view cube. This looks pretty good. Move the playhead to 1 second. Now let's select the transform components and choose this pin. Position it using manipulators. Make sure that you are moving it in right direction. In this case, down because it is tapered, and click OK. If you move your playhead, you can have a view how it transforms. Let's move the playhead to some distance. Select the other pin and transform it. Change the position using manipulators. In this case, positive z-axis. Repeat the same for all components by moving the playhead a bit. Now, I want to transform the fork pin. Change position by manipulating it. If you notice here, the entire component is moving because it created as a body underneath fork pin. Let's make that correct. Switch to design. In order to move only the fork pin, we need to create a component from body. Let's rename it as pin. Expand fork pin to observe that it created component here also. That is the advantage of copy and paste. Now switch to animation workspace. Repeat transform components. Now select the pin. Only the pin is moving, right? Yeah, perfect. Repeat the same for another pin, and for 2, try to manipulate the transforms. For better animation effect, you can move the components however you like. Let's play the animation. It looks awesome, isn't it? If you notice here, we're having storyboard 1. We can create as many as storyboards we can. Rename it as assemble. Copy it and paste here. It creates a duplicate for the first one. Change it to reverse. Then play the animation. If you notice here, it just reversed the animation. How nice and clean. I wanna rename it as disassembly. Let's export our animation. You can do for current storyboard or for all. Choose the desired location if you wanna save to your local computer. When you're done, the video will be processed and saved. Let's check the exported video. It looks awesome, isn't it? Now let's switch back to render and open the render gallery. The rendering is completed. Just click on it and choose download for saving it locally. Choose the desired location you wanna save there. Perfect. Let's open the render which is saved in our local computer. It looks good for me. Now I'd like to produce drawings for the design. Under template, choose browse, open 10 tips and select sample 1. Sample 1 is a template which we've created while doing top 10 tips in Fusion 360. If you haven't seen that, I'll give you the link in the description, or you can find it inside info in here. You just have to watch tip number 1 in order to create sample 1 template. Now click OK. Fusion will create all the drawings according to the template. You can make necessary changes to your drawing. Let's increase the scale to 1:1 and position them so that they do not overlap. We are having many drawing sheets created in here. If you notice this sheet, it's created based on our storyboard 1. Let's check by switching to animation workspace. Notice that the position of these components at the end of the storyboard are same as that of the drawing created here. We can add dimension if required. If you observe this dimension, we are getting align one. Just right click and select horizontal and place it on the sheet. Maybe I'd like to increase the scale of this drawing to 2:1. Position it so that it looks nice and clean. I'd like to export this sheet. You can export current sheet or all the sheets at a time. I'd like to check open and when it's done. Then choose the desired location. I'm gonna rename it as UGISO. Then hit that save button. This is how it looks like when you export it. You can print it right away if you want to. Congratulations! You learned many things today. Let's say my client requested me to change the shaft dia. You don't need to change the entire design. You just need to modify the parameter of that shaft dia. Let's say 30. And hit enter. Automatically updates everything. You can have a look. I'll change it back to 20. Notice that the size reduced. This is because we linked the shaft dia with all the parameters inside design. You can produce any shaft dia you like. I think you learned something from this video. If you do so, consider liking. If you'd like to get notified each time when we upload new video, consider subscribing to our channel. It helps us a lot. If you like automobiles, then this video is probably for you. If you like organic designs, then this generative design video is for you. Here's our latest video, which is fantastic. I want you to take a look at it. I hope you never regret this. Thank you so much. See you in the next video. Goodbye.